In this problem, we want to use the chain rule to find the derivative of the function L of x is tangent of e to the x over x squared plus 1. So for the chain rule, we notice that our outside function here is tangent of u, with our function u inside function being e to the x over x squared plus 1. So by the chain rule, L prime of x should be the derivative of tangent, which is secant squared, of u, which is e to the x over x squared plus 1, and then times the derivative of e to the x over x squared plus 1. Now for that derivative, we have to use the quotient rule to figure that out. So you'll end up with a secant squared of e to the x over x squared plus 1 times low x squared plus 1 d high e to the x minus high e to the x d low 2x over the bottom squared x squared plus 1 squared. So you could leave the answer like that, or you can simplify it a little bit by factoring e to the x out of the numerator, leaving us with an x squared minus 2x plus 1 in the top, and x squared plus 1 squared on the bottom. That top is x minus 1 quantity squared. So our final answer could look something like secant squared of e to the x over x squared plus 1 times an e to the x, and then times an x minus 1 squared over an x squared plus 1 squared. And that's how you can work out that derivative using the chain rule, where there's also a quotient rule involved in that application of the chain rule.